Hi, I'm Miss Hearn. Let's get started. And if you find this video helpful, please remember to give it a thumbs up. That helps other students to find the video. So here's another one. It says find the derivative of k of x equals 1 minus x over 2x. Then find k prime of -1, k prime of 1, and k prime of square root of 2. So remember, when you find the derivative, you're going to get a function. This is asking you to find k prime of x, the derivative. It did not specify at a particular value. So what you would do is you'd find the limit of the difference quotient with just x's and h's, not plugging in a particular value. But then at the end, we can use that function that we find, the k prime function, and plug in and see what values we get. Okay, so let's try this. So first, k prime of x is going to be the limit as h goes to 0 of k of x plus h minus k of x divided by h. So we're going to work through our process here. K of x, we were told, is 1 minus x over 2x. Step 2, we're going to find k of x plus h. Let me give you a minute to figure out k of x plus h at home. I want to make sure everybody's doing this correctly. It's going to be 1 minus, instead of an x, we have an x plus h, over 2 times, instead of an x, we have an x plus h. So it should be 1 minus x minus h over, and I think I'm going to leave the denominator factored until I see what's going to happen. That's often helpful. Okay, now we're going to go on to step 3. We're going to take k of x plus h minus k of x, and then we'll divide that by h. I'll write that in a minute. So we have the second step minus the first step. So it's 1 minus x minus h over 2 times x plus h minus 1 minus x over 2x. You can get a common denominator and subtract, but I prefer not to do that. What I like to do is just go ahead and write it over the h. And then it's now a complex fraction, which can be simplified by multiplying the top and the bottom by the least common denominator of the little fraction. So the least common denominator for 2 times x plus h and 2x, which is going to be, it's going to have a 2, it's going to have an x, and it's going to have an x plus h. Now I'm going to write out an extra step just to make sure everybody's following the algebra. You do not have to write this step. This is just to make it more clear, because this tends to be a part of the problem that people get a little nervous about, the algebra. Okay, so I've distributed the 2x times x plus h to each term in the numerator. In the denominator, I do not FOIL that out because we like factored form. So the denominators cancel, and we're left with x times 1 minus x minus h minus 1 minus x times x plus h over 2hx times x plus h. Okay, and then the fourth step is to take the limit of that. Although we're going to need to simplify, I'm just going to do it as I'm taking the limit. I'm going to write the notation k prime of x here. K prime of x equals the limit as h goes to 0 of, and I'm going to rewrite all of this stuff. I'm going to go ahead and distribute. So I have x minus x squared minus xh. And then on the right here, well, actually, you know what? I'm just going to bring that negative in. So this is going to be plus, and it's going to be x minus 1, x plus h. That's easier for me to FOIL that out, but you can do it however you want. All right, so this is going to be x squared minus x plus xh minus h. Keep copying down that limit there. Okay, we're going to combine like terms. Every term that doesn't have an h in it should cancel if we did everything right. Looks like this one's going to cancel as well. So we're just going to be left with negative h in the numerator. Okay, the h's divide out. So we have the limit as h goes to 0 of -1 over 2x times x plus h. Now we need to plug in, and remember we're only replacing the h. So it's going to be -1 over 2x times x plus 0. So we have k prime of x is equal to -1 over 2x squared. All right, now we're going to find the slope of k at various points. They told us to find k prime at -1, k prime at 1, and k prime at square root of 2. So let's go ahead and do that. All right, so let's start with k prime at -1. So it's going to be -1 over 2 times -1 squared, which is going to be -1/2. K prime at 1 is also going to be -1/2. And then k prime at square root of 2 is going to be -1 over 2 times square root of 2 squared. That's going to be -1/4. All right, so this represents the slope of the function k at x equals -1. This represents the slope of the function k at x equals 1. And this represents the slope of k at x equals -1/4. Notice that I just said slope of k. I could have also said slope of the tangent line to k. Those mean the same thing, but for brevity, we often just say slope of k. All right, now here's a picture of k, by the way. Remember, k was the function 1 minus x over 2x. And let's just see if these slopes seem reasonable. Let's look at -1. So when x is -1, we're over here on the graph. I'm going to draw in a tangent line. And supposedly that tangent line has a slope of -1/2. Okay, so rise over run. If I go over and down, it's a little off, but we're going to the right 2 and down a little bit more than 1. But of course, mine's just an estimate because I'm just drawing that in. So that would be a slope. It's definitely negative. And we're going, the rise is -1 and the run is +2. So -1/2 would be reasonable. Okay, let's look at 1. Here's 1. If I draw in a tangent line there, and look at that, it looks about parallel to the other one, doesn't it? Parallel lines have the same slope, so it makes sense this would also have a slope of -1/2. And then let's see, what is square root of 2 in decimal form? It's going to be about 1.4. Square root of 2 is about 1.4, so that's going to be about, let's see, here's 1.5, a little less than 1.5, maybe about here. Is that the axis here? Here's the function. It's hard to see. Okay, the function has flattened out even more than it had at 1. Still has a slightly negative slope, but even more shallow. So it makes sense that that slope is -1/4. If you found this video helpful, please give it a thumbs up. That will help other students to find the video.